everyone. The perimeter of a given square P can be represented by the function P of A equals 4 times the square root of A, where A is greater than or equal to 0. So basically we're starting here and we end, this is your domain. All right, and A is the area of the square. The graph of the function is shown for A is in between 0 and 25 inclusive. So from 0 to 25. This is going by 2, so there's about 25. All right, and we're going to answer these 3 questions. So the first one's easy. It says find the value of P of 25. So we know that P of A equals 4 square root of A. Again, A is positive and it can equal 0. All right, so all you're going to do is substitute 25 in. So P of 25 equals 4 times the square root of 25. All right, so this equals 4 times 5, which equals 20. Now, the next step is we're going to graph the inverse. So the first thing I want to do is algebraically find the inverse. So let's just let this look like, for now, we have, let's say, y equals 4 square root of x. And then x would be greater than or equal to 0. So to find the inverse, you just switch the x and the y. So when you do that, you're going to get x equals 4 square root of y. This is your inverse. To make it easier, though, we're going to make y the subject. So solve for y. Divide both sides by 4. And then you square both sides. So if you square both sides, you're going to get y equals x squared divided by 16. And that is your inverse. And we're going to actually use this a little bit to explain C. So let's go to the graph. So for the graph, what you can do is, because you're just switching the x's and the y's, you can do a table of values. And we're going to let this be A, and your output be your P of A. And I'm going to use simple numbers. So I'm going to use 0. I'm going to use perfect squares. So I'll use 4, 9, 16, and then 25. Now we already found 25. That was 20. Now we just use the P of A is 4 square root of A. So let's solve all that. So you plug in 0, you'll get 4 times 0, it's 0. When you plug in 4, the square root of 4 is 2, so 2 times 4 is 8. Plug in 9, that's going to be 3 times 4 is 12. And square root of 16 is 4, so 16. It keeps going up by 4. So let's see if this one's right. 4. All right. So basically, that's how it's going. Now, to do the inverse, what you do is just switch the x's and the y. So we can say move the P of A, just like we did earlier, P of A here and A here, and just switch the numbers around. So you get 0, 0, 8, 4, 12, 9, 16, 16, and 20, 25. And just plot these points and then draw the graph. So we have 0, 0, 8. This goes by 2s. 8 maps to 4, 2, 4. 12, so this would be 12. 12 maps to 9. This would be 8, so 9 is about there. All right, 16, this is 2, 4, 6. So 16 maps to 16, 2, 4, 6. So that matches up. These two match up. All right, and then 20 maps to 25. So this would be 2, 4, 25 is about here. And we want 20, so it's going to be right about there. So about there. 2, 4, nope, right there. All right. Now, connect everything. And we're going to get something like this. All right, so that would be a little sketch of the graph. And notice that on inverses, they reflect over the y equals x line. Okay, so there's your graph. And now it says, in the context of the question, explain the meaning of the inverse of p of 8 equals 4. Well, basically looking at the table, that's what it means. So if this is 8, then your output is going to be 4. You could also use our inverse we got earlier, where we had p inverse of a equals, and that was 8x squared divided by 16. So plug in 8 here. So you're going to get p inverse of 8 equals, and you plug in 8 squared divided by 16, which is 64 divided by 16, and that equals 4. And that's it. Thank you. Have a nice day. Bye-bye.